everybody. I'm super excited. This is my first time in the region, and I'm happy to talk to you about a little bit of the work that we're doing at Nokia and at Bell Labs in general. I want to talk to you about some of the ways that we're thinking about AI a little bit differently. I want to think about how humans are in the loop with the systems that we're building, and I want to touch a little bit on responsibility, which is obviously a key concern with lots of these systems. So I want to just start by mentioning that everyone's saying it. Obviously, something is different. Even Bill Gates is saying it. He's saying we're living in an age of AI. And with this age, obviously, comes a whole host of new opportunities. And lots of what people are talking about is how excited they are about AI, how much value we can create going forward, and how interesting it is of a technology. But it also comes with new responsibilities to kind of rethink the impact that it's having on societies, but also responsibility that us as technologists have to make sure that we deliver these technologies in the most responsible ways possible. And so what I want to talk to you a little bit about is some of the problems that starts with AI. And I just want to give you a few examples, and we'll maybe use this as a blueprint for how we're thinking about moving things forward. So autonomous cars, San Francisco, they're rolling out trials. They're well known that there's lots of problems. This is a particular example that was reported by the New York Times that two stopped in the way of an emergency response vehicle, right? And the emergency response vehicle was unable to get out until they called the operators and actually, remotely directed these cars to move. So how come when AI gets into trouble, it's unable to do something different, to kind of think outside the box here? Second example I'll give you here is from, was reported by Global News, actually a Canadian organization where I'm from, about this chatbot that they had built to help people with eating disorders. Now this chatbot went a little haywire when it actually, an activist, maybe prompting it a little suspiciously, got it to recommend a calorie-reduced diet to this person, which is quite a harmful thing to recommend to a person already with an existing eating disorder. So how come these models are so difficult or have so much trouble when there's bias and uncertainty in the data sets? And what do we do about it? And then maybe as a little bit of a positive example, when we think about humans and the way that we solve problems, we're able to do complicated things, and we're able to use these complicated things and master them to the point where eventually these complicated things become simple. So take Garry Kasparov. He was a chess champion for many, many years. There's a funny story, perhaps maybe not so funny for the people he was playing, but he played 30 people simultaneously, and he literally walked around the room, just looked for 20 seconds, put the next chess piece, and he beat them all. He played 30 games simultaneously and beat them all. So existing machine learning models don't really do that. Of course, yeah, they're way better than us at chess, but they don't really improve consistently. They're not taking information from the environment. So how do we build machine learning models that keep learning, keep continually iterating, and eventually start to master the complex? Now, it turns out there's a good framework for how humans have done this, and it's brought to us by Daniel Kahneman, a Nobel laureate who won a prize for his body of work that described how humans think about the world and how they solve problems. So the way that we solve problems is through this idea of two systems. So we have system one, which is my fast thinking system. It's the system when I say 1 + 1, that 2 came to your mind, and you didn't think about it, you didn't actually have to compute the answer 2, it just kind of came to you. It was readily available, it just popped into your mind. Now, this system is fantastic. It's what we use most of the time. It's what's talking right now, thankfully, so I don't have to think. But it's also incredibly error-prone. It makes biases. It's the reason why social media is so addictive. It's the reason why marketing works through the idea of nudging, etc. Now, the other system, if I said, on the other hand, 17 times 24, most of you could probably come to the answer, but it would probably take you some effort. You'd need to kind of go into yourself. You'd have to do this other type of thinking, this deep, focused thinking that allows us to do something different when we arrive with challenges. So that's our system 2. It's our deep thinking machine that allows us to attack these new challenges. And it's also the system that we use to kind of monitor our system 1 for things like biases, for errors. It's the reason why we take bias training, so that I can enhance my system 2, that when I start to speak and I start to get close to a boundary, maybe my system 2 kicks in to monitor. And so we actually use this system fairly irregularly, but it really helps us guide the way we act in the world. And so what's important to take away here is that the way we as humans attack the world is through this complex interaction between these two systems. You have system one, which works all the time, and system two, which pipes up and does something different. So what I want to propose to you here is that the future of AI and machine learning is not just the scaling of system one, which I would argue that things like ChatGPT and lots of these generative models is just simply the scaling of system one, which is why we see lots of these problems with bias, with hallucinations, and other problems. But the future of AI and ML is in the building of system two. Systems that allow us to, for example, build models of the world, so ethical models, physical models, and to then use these models to reason about the real world and then transfer them when necessary. Systems that allow us to focus on the most important pieces of information. Instead of collecting all the world in the data, or all the data in the world, rather, we will focus on the most important and use those to solve the problems that we're interested in. Things that learn from cause and effect, and then transfer those cause and effect relationships to the real world. And then finally, things that can recognize errors and biases. And then once we've recognized those, we can re-update, we can relearn, and we can change what we're doing. So what I want to do in my remaining time here is I want to talk about some problems that we're attacking inside of the labs right now. And I want to just give you two easy examples, things that are easy to digest, but they reflect how we're thinking about the world with respect to this different framework. And I'll show you how they help us learn how to use things like large language models and to use them in the most responsible way possible. And so the two examples I'm going to give you are, number one, about assessing risk using language models. Remember I said system two should be like a checker in the background. So the first step is obviously developing models that help us to assess risk. And then once we've identified perhaps that there's risk, we'll go on to the second one where something is perhaps more critical, more important. I want to act in a slightly different way. And I'll show you how we're going about this right now. Okay, so AI risk, it's a hard topic. There was a pretty good panel an hour ago or so where they talked about risk and the difficulties of risk. Why don't developers or lots of people always get into a discussion of risk? Well, it's time consuming and it's hard, right? It's time consuming, resource intensive, right? You need many people. But also you probably need specialists, right? You need lawyers and other people who are, understand the literature, can read things like the EU AI Act and understand, what are the regulations and what are the specific risks involved, right? And so this is, you're trying to intersect two domains and this becomes complicated. So what we did was instead, let's think about this as a system one, system two, and let's build a second model that helps us to evaluate the risks associated with a particular project that we're going after. Now, there's this brilliant piece of research that went through the EU AI Act that said that if you're going to understand this act, there's essentially 5 topics that you're going to need to understand about your problem. So the domain, where are you at, the purpose, the capability, and then the AI user and the AI subject. So the AI user is the person who's developing it, like the company, and the AI subject is the user on the other end, right? Your customer usually. And so here we've pre-filled it out with the eating disorder use case that I had given you prior. And what we were able to do is we were able to build a language model that most importantly just pulls out the classification. There's other information. It gives you reasons and explains what's happening, etc. But it acts as this system 2 flag. So it gives us the most important information and said, look, you're building this use case, that's great, but we need to flag it as high risk, and maybe you need to think slightly different about this use case with respect to risks, etc. The second use case I want to talk about is, okay, what do we do then? We flag something as high risk. How do we do something different? So I want to talk about acting different in high stakes situations. Okay, and so the example I'm going to give is not really high stakes, people tell me, but it's high stakes to us, and I'll explain why in a second. So the problem we're going after here is the idea of building a language model that's going to be a chatbot with our customers. So for us, because Nokia builds equipment, it's going to be a service chatbot. Now, not particularly high risk, but it's high risk for us because, of course, if you're selling something, you want to produce a service chatbot that's reliable, right? So things like correctness, things like specialization, because the language we speak inside the company, perhaps people, other people won't understand, but certainly language models don't understand our private corporation knowledge, right? And so we need to make sure that that's baked into our internal chatbot. And then most importantly, accountability. The customers that we sell to, when we produce a chatbot for them, we need to produce something that we know where it goes wrong so that we can fix the problems as they occur in this chatbot. And these are things that we just couldn't access using the outside System 1 systems, right? Things like these large language models on the outside. Okay, so this is our digital assistant that we were able to roll out very quickly. It uses Nokia internal documentation. And as promised, it acts a little bit differently. So how does it act a little differently? Well, we build our own language model on the inside, and we do this maintaining all those principles that we need, the accountability, the accuracy, but also it's specifically built on our own languages. And then we use this in combination with the outside systems. Because remember I said humans don't pick one or the other. The way we interact with the world is a complex interaction between these two systems. So we use existing language models because they're the good chatty interface to the outside world. And in doing so, we actually achieve a language model that is able to do exactly what we want. It's able to provide concise and accurate answers in natural language for Nokia-specific questions. And this is super important for us because obviously we want to provide the most important information. So if I take a step back and say, okay, I'm trying to build these System 2s. I'm trying to build them in conjunction with the fantastic work that has been done around building these System 1s going forward. What do I need to do, or how do I know where to go? Well, you need a guiding framework. And for us, it's our 6 pillars of responsible AI, which incidentally are well matched to everyone else's pillars of responsible AI. So these are not uncommon principles. Perhaps sustainability, I feel it's not talked about enough as part of our principles, but we use this as the guiding principles for what should our System 2 AIs be doing. Because the point of building these systems is, of course, ideas around compliance. Of course, it's ideas around trustworthiness, right? That's why we want to build responsible systems. And of course, there's all these ideas that building these systems allow us to operate faster and in our development cycles and roll things out quicker. But the point, and maybe this is the one takeaway if we're rethinking the use of this generative AI, the point is not that we're simply going to scale our way out of these things. We're simply going to build larger language models and all our problems will be solved. The whole point is not to build these perfect systems, but rather to build systems that are continually able to improve, systems that are able to assess themselves and make changes. The point is to build the most responsible systems possible. And with that, I will thank you for your time and for inviting me to your region.